In this question, I'm going to graph the curve y equals 1 over 1/2 x squared minus 3x plus 5. Now, before we get any further, if we were to see 1 over 1/2 x squared minus 3x plus 5, that would look a little unusual because usually we see curves written, fractions written without fractions inside. Probably what would happen, if you were to see this curve, it would probably look like this, 2 over x squared minus 6x plus 10. If you saw a curve that read y equals 2 over x squared minus 6x plus 10, you might say to yourself, hey, I have a 2 up there, and that's not the series of steps I learned. I learned how to graph reciprocal functions if there's a 1 up there. But what you could do when you see a fraction like that is multiply that 2 by 1/2 to make it a 1. But because you multiplied the numerator by a half, you'd have to multiply the denominator by a half, and you would end up with 1 over 1/2 x squared minus 3x plus 5, okay, which is what we're being asked to graph. So again, like I'm saying, if you were to see this curve, in nature, so to speak, it would probably look like this, and you would then multiply top and bottom by 1/2 to make it look like that. So we're just skipping that first part and just graphing 1 over 1/2 x squared minus 3x plus 5. Okay, so let's get to the question. I'd like to know the vertex of that parabola 1/2 x squared minus 3x plus 5. So one thing I can do is I can factor out, there's an x squared here. What I can do is I can factor out 1/2 from the first two terms. I'm going to complete the square, but you can do any method you want, including partial factoring. Now what I'm going to do is I'm going to take this coefficient of x, and I'm going to divide it by 2. When I do that, I get -3. I'm then going to square that -3, and I get 9. So that tells me that I want to rewrite my curve as 1/2 bracket x squared minus 6x plus 9 minus 9 plus 5. I can then distribute out that 9, and I end up with 1/2 x squared minus 6x plus 9. When I distribute out the -9, I multiply it by a half. I get -9/2 plus 5. And so what I end up with is 1/2. This is x minus 3 quantity squared. And -9/2 plus 5 is equal to plus 1/2. And so I find out that what I've got is a parabola with a vertex at 3, 1/2. That opens up because we see that the lead coefficient is positive. So this is what it looks like right there. Now, what I then do is I want to make sure that I draw a vertical asymptote at every x-intercept, but there are no x-intercepts. So we skip that step. And in the next step, we go to every point on the curve where the y-coordinate is 1. Okay. Now, this curve has a minimum. We can say the curve y equals 1/2 x squared minus 3x plus 5 has a minimum at the point 3, 1/2. Well, the curve 1/2 minus 3x plus 5 and 1 over 1/2 x squared minus 3x plus 5 are going to have an inverse relationship. As one gets bigger, the other gets smaller. So if I make this a 1 over, then this word minimum is going to change to maximum. But I also have to, I can leave the x-coordinate the same, but I have to put 1 over the y-coordinate because we're graphing 1 over x. 1 over f of x, which is 1 over y. So 1 over 1/2, what does that equal? 1 divided by 1/2 is equal to 1 times 2 over 1, which is 2. So what I'm saying is that this curve that I'm trying to draw is going to have a maximum at the point 3, 2. So I go to the point 3, 2 on my graph, and I do this, and I indicate it. Now what I want to do, from the vertex of this point at x equals 3, the blue curve goes up to the left. So my curve needs to go down to the left, but it also needs to respect that horizontal asymptote. And on the other side, from the vertex, the blue curve goes up to the right. I want mine to go down to the right, but also respect that asymptote, that horizontal asymptote. And it's sometimes tough to make it maintain a curvy looking thing, but we do our best. And so this is what the curve ends up looking like. Now, what we want to do now is state the domain and range. Well, the domain is the set of all x element of the reals. This curve has no values of x for which it's undefined. The range is going to be all values of y in between 0 and 2. We can include a y value of 2 because at x equals 3, the y coordinate is 2, so 2 actually does appear as a y coordinate. But we can't include the y value of 0 because y equals 0 is a horizontal asymptote, and we don't get there. Now, our increasing intervals, we can say x is an element of the interval from negative infinity to 3. We put a round bracket on 3. I actually think we should put a square bracket on the 3 because I think 3 is included by definition in the increasing interval, but your textbook doesn't think so, so we'll allow both. Our decreasing interval is going to be any x coordinate between 3 and infinity. And once again, for the same reason, I think the 3 should have a square bracket. Now, our positive interval, what x values produce a y value greater than 0, they all do. Any x coordinate from negative infinity to infinity is defined and produces a y coordinate that's positive. Negative intervals, there are none. And our horizontal asymptote is at y equals 0, and there are no vertical asymptotes.